10 to 15. If I get to 10, Stuart, you just shoot a flare up.
We have.
So I'm going first because I'm sort of the most. I'm going first because I'm sort of the most beginner, and my kind of desired outcome of what I'm going to talk about is to alleviate the fears of anyone that's interested in getting started or doing more. That it's really not as sort of difficult as a lot of people make it seem. It's kind of like chess. It's like really easy to learn, but impossible to master and sort of get to the grandmaster level. So my really desired outcome of this meeting is to say, it's okay if you stink. So here I am, I stink. So yeah. So I've been doing astrophotography for only about a year and a half, maybe 2 years. Again, I want to talk about how I got into the hobby, what astrophotography really is. I'm going to talk very briefly about the equipment that I use, show some of my images. I've also have my images displayed in the order that I've taken them, so you can kind of see the kind of craft along my journey. And I also want to talk about what I enjoy so much about doing it and why you might enjoy it too. So I see some young people here with their parents. So if Stuart's question is, why should I sort of experiment with astrophotography, it's this. Because this is definitely true in my case. It is a little bit of a misconception, a little bit, so it's a good joke, but it's a little bit of a misconception. The fact is that if you were to walk in cold as a non-photographer or a non-astronomer, yeah, it's going to take some entry cost to get into this hobby. But as a photographer or an astronomer, you should have half the gear already. So it's a little bit of a misconception. It certainly can be an expensive hobby, but it doesn't have to be. And what astrophotography really is take the astro off of it. A lot of people think it's an offset of the astronomy hobby. I actually think it's more an offset of the photography hobby, right? So all astrophotography is a long exposure photograph. Most long exposure photography, by the way, these images aren't mine, used motion effects to capture some sort of artistic effect. This is a long exposure photograph of a river. The water kind of blurs as it moves. Here's another example of a long exposure photograph that uses a motion effect. This is a dynamic lighting situation where you have very low light and a very high light illumination in the photograph. This also has motion effects. This is low light with motion effects as well, but we have the sky in it, so you can kind of see the travel that these images are going through. The next image is kind of the gateway drug to astrophotography, which is a star trails photo. This is a low light situation where there is motion effect, but the motion is by the Earth technically, but it's more the effect of the stars in the sky. Now, if you can control for the motion of the sky, you have an astrophotograph. So now, again, there's nothing different in this photograph with the river photograph or anything. So this is all photography, a subset of the photography hobby. And then really all you need to do to get into deep sky object photography is add a little zoom, and that's all you got. So again, not one of my images, but you can kind of see that this is really nothing more than taking a long exposure photograph and trying to control for the motion of the sky. This is all the equipment that I own. I break this equipment down into 3 astrophotography rigs. There's the one that makes me swear the most, which is the most heavy auto-guiding. It has a piggybacked short tube scope that I use to auto-guide, which never really works well, so what are you going to do? I do shoot with just the regular camera that I take to the zoo. It's just the DSLR with a T adapter and a T-ring on it that sticks out of the back end of my telescope, and I use this MacBook virtualized to Windows for capturing the data. So I use a program called Backyard EOS, which basically just controls the camera, and PhD, which stands for Push Your Dummy, which is the auto-guiding. If you take out the reflector and you take out the auto-guiding rig, it's my second rig, which is with a TeleVue 76, which I bought at the DAS auction. And then my third rig, which is the easiest, which is really not an astrophotography rig, it's really a photography rig. It's just a camera tripod, my DSLR, and the kit lens that came with my Canon camera. I do have an Ioptron Sky tracker, which is basically a tiny little white box that you put on the tripod, you angle it to Polaris just like you would a German equatorial mount, and it slowly rotates the camera. It actually rotates the camera either exactly with the sky or half speed to the sky. And the theory about that is if you're going to get motion blur, you're going to get motion blur either with the stars or with the landscape. And if you do it half speed, you get half as much blur on both, as opposed to a lot of blur on one or the other. So the next series are images. Again, these are the images in order that I ever took them. So this is my M42. All the images that I took are not really long exposure, like you're going to hear some of these guys talk about 5-minute, 10-minute captures. I've only started to get the gremlins out of my auto-guiding rig. So most of these images, I think the longest exposure I have in one of the other images is 2 minutes, but most of these are 30 seconds, 60 seconds, and stacked. And I'll talk about what stacked means. I'm so glad that Roger Clark is in here because he would be, this is like a Roger Clark crime, is to shoot at ISO 100. So I learned that lesson. I shoot now only at ISO 1600 lest I get on Roger's bad side. The next project I did was actually just a video. So this is, hopefully this is going to play. Yeah, this is the occultation of the star Alkebash, which is, I think, Lambda. It's a Gemini. Oh, so that little star over there, this is just a real-time video loop of that star blinking out. So if you've never actually visually observed an occultation, it's kind of neat. It's the dark edge of the moon slowly traveling toward that star, and when it covers it, it blinks out. So none of this is stacked. This is kind of a real-time video loop of what it looks like on the LCD of my camera, essentially.
Seeing was kind of shaky that night, wasn't
it? Yeah, welcome to Colorado. Yeah. The next project, this is probably the most difficult project that I've done, which is a time-lapse video of the tax day lunar eclipse. This looks like a time-lapse video, but it's kind of not. It's really cheating. And what it is it's probably 30 images, and they all slowly dissolve into one another to make it look like a time-lapse. So, you know, the kind of travel of the terminator of the eclipse is dissolving in and out. It's just a series of photographs slowly dissolving. This was taken with a 10-inch astrograph, Atlas EQD mount. The most difficult part of this project was after I got all the images stacked, aligning them so the moon didn't really shake around in the frame. So there was a lot of just manual rotating and moving it around. But this was a really fun project, and I'm happy with the result. I think my best technical photograph is the next one, which is M13, Glob and Hercules. I think the reason, one of the tricks that I've kind of learned to getting really deep and dynamic images like this was taken in my backyard in Lakewood. These are not dark sky conditions. There's no light pollution filter or anything, but it's actually 3 different exposure sets. So there's one really overexposed to get really the tiny, tiny, tiny hazy stars, and then one that's underexposed where you get more detail in the core, as opposed to having the core blown out and kind of shotgun buckshot around it. So I think that the dynamic detail of the small and large images of what stars in this image is technically good. When you get into the real astrophotography snobbery, you're going to get into what's called pixel-peeping, which is when people look at the very edge of your photograph and kind of criticizing it for it looking like a badminton, a badminton shuttlecock at the edge. That's coma. There's not much you can do about it unless you buy a real expensive coma corrector or correct-worthy software. I'll talk about what I really like about astrophotography later, and you'll find out that my answer to the pixel-peeping crowd is out here. This next image I took with just the camera tripod and the Ioptron tracker and just the kit lens. My wife and I were camping by sand dunes, and I just set this up, and it's 1 frame, ISO 1600, 2-minute exposure. It has really good color contrast. I was happy with the color contrast. You can't really see it in this projector. It looks a little blown out, but the composition I was going for was trying to get the Dark Horse Nebula kind of in the top, the rule of thirds photography-wise. I'm pretty happy with how the Dark Horse came out. This is it's photoshopped, air quotes, not really with Photoshop, but it's photoshopped a little bit to get some of that dark. To get some of that dark nebulosity out, but it's not kind of color painted. You'll see some other landscape astrophotographers that really take a lot of liberty with painting, but that's not with this image. The next one is the only image that I've taken at the dark sky site, and here's the problem with working at the dark sky site is you can't see, and you can't see if you're in focus or not. So this image is actually a little bit out of focus, but I took this with, again, the astrograph, which is f/3.9. So this image really deserves kind of a 5-frame mosaic. So this is just the core, but happy with how the dark lanes came out here in the core. All right, let's keep moving. This is M31 again, this time with the teleview. It's a little zoomed out. I'm really not happy with the processing of this image. It's on my to-do list to reprocess it. You can see a lot of color model, which is like color noise, especially up in the companion galaxy up top. You can just see it looks like it's a picture taken with the intent of wearing those red, blue 3D glasses on them. That's bad color control in your processing.
Are you pixel peeping?
Exactly. Yeah. I'm allowed to pixel peep myself, but I'm not here to be judged. This is Lovejoy taken on Christmas Eve. No tail, again, from my backyard, but it was my first time processing a comet. You have to do it differently because the comet itself moves against the background image of stars. So when you process it, you have to process the comet separately, get an image, the stars without the comet, get an image, and then combine them. So that's my Lovejoy. Oh, one other thing I want to mention is this image and the next 3, so 4 total, were all taken on the same night. And it was probably a 3-hour night. So again, getting into astrophotography, you don't have to think of yourself driving out to the dark sky site, staying for 8 hours and then going back the next day. Joe will tell you that you have to do that to get his quality images. Maybe not have to, but if you really want to collect a whole lot of data, gorgeous, gorgeous CCD images, it takes a lot of collection. But this kind of entry-level stuff, these next 4 images were all taken in about 3 hours. This is M15, and this is Pleiades. So I wanted to talk a little bit, not technically, but just entry-level about why you stack astrophotography images. And it's signal noise control. So for those people that have never done astrophotography, this is a picture of my dog in a tuxedo. And this is what noise looks like. It looks like the static on your TV. So what I did was I combined these 2 images and I made 1,200 images that look like this, except the noise is different in every image, which is what it's going to be when you're taking a dark, a low light photo. So that image doesn't look like a very good picture of a dog in a tuxedo, and the other 1,199 images also look like crap images. But what happens when you stack them is because the noise is random, it averages out the entire noise set and leaves you with not the full signal, but the signal is amplified against the noise. So I'm going to go to the next slide, and you're going to see it's a doubling effect. So you're going to see what it looks like when you stack 1 image, which will click this, 2 images, 4, 16, 8, 16, so on and so forth. So this is 1, this is 2, this is 4, this is 8, 16. You can see that the noise gets reduced with the more images that you stack. Again, this isn't a trick where I'm just pulling back the noise frame out of the dissolve of the photo versus the noise. I actually did go in and stack these images in photo stacking software, so you can kind of see what the effect is. Now, once you're done stacking and you have an image, stacking first, then processing. I actually like to call it post-stack processing, because a lot of people think that processing is the stacking and the processing phase. It really does make a difference. So this is the same data set. This is my very first astrophotography image. This is the first time I processed it before I knew what the heck I was doing. And then this is the second version that I processed. I really don't think that the software package you use to do it makes a difference. I like this software package, PixInsight, more than Deep Sky Stacker. It was just a little bit easier for me to use. It actually is a pretty difficult piece of software, but it just made sense to me. So you can think of processing as kind of the like photoshopping step. You have one image, let's say you're shooting a portrait, right? You get the portrait on your computer, and now you're doing things like getting rid of the red eye, maybe getting rid of some wrinkles, maybe getting, putting the lose 10 pounds filter on the photo. That's kind of what you're doing to your astro image. One of the things that's difficult in doing processing is losing the color contrast. I'm not going to go into it in detail, but if you find yourself processing images and all of your images are white, or all of your stars are blue, or all of your stars are white, or all of your stars look yellow, that's a common problem. One of us can talk you through how to solve it. So the last thing I want to talk about is why should you try astrophotography? And I have no better answer to the question, why do I do astrophotography, than I just enjoy it. I get delight out of it, so why not? I'm never going to be one of these people like Joe or Sorin or Daryl that have gorgeous, technically wonderful, craftsmanship images. I think that those people are kind of the artists of the astrophotography world. They're guys like Roger or Christopher Go, or images you look at from Hubble. They're meant to inspire, and they're art pieces. There's also kind of the craftsmanship astrophotographer that has the latest gear and slogs out there on a regular basis and knows all the technical details and all the math behind every pixel, and they're trying to drive the frontier of the technical craftsmanship of astrophotography. And I kind of feel like people get threatened with the hobby by saying, I either have to produce images that look like Hubble, or I have to spend $25,000 on gear to push to the forefront of astrophotography. And I, again, really don't care about either of those things. I just do it because I really like it. And I thought long and hard about why I like it so much, and I come back to The Pale Blue Dot by Carl Sagan. Now, okay, before you call me a crazy person, this is kind of what got me into the astronomy hobby and just sort of space science hobby in general, which is The Pale Blue Dot piece by Carl Sagan. And I think the reason that Carl wrote it, and I think the reason it resonates with so many people, is it bursts a bubble that we all have, that we matter. Right? I hate the piece sounds so negative, but I think that this is why the piece is so beautiful. Is it's saying, you really don't matter at all. So who gives a crap if your astro images are good or not? Just go out and have fun. So, one of the lines that's not in this part of the poem is, our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this pale point of light. And this is the exact reason why I really enjoy astrophotography. I have a very, very high pressure, highly technical job where I go to work. I'm responsible for multi-million-dollar software implementation projects. I get very stressed. I'm always looking at my phone. I always have thousands of emails in my inbox. I always have a million things to do. And what the hobby does, astronomy and astrophotography, is kind of the same thing that, yoga does, or going to a museum and looking at beautiful art. But for this crowd, it might not be the right-brained, heavy crowd. It might be a little bit more left-brained heavy. So I put it this way, which this is entropy, or written another way, it's this. So, the fact that I have 1,000 emails in my inbox, or have a bunch of tasks to do from work, or having a high-pressure situation at work, I tell my employees this when they're stressed out. I say, hey, look, don't forget, the universe will eventually end in heat death and no one will remember anything that you've done. And it sounds negative, but you can really turn it on your head and make you feel really, really empowered and make you feel like you can just go out and feel no judgmental responsibility to anyone else on the planet. So I think you should go out there with your cameras and take pictures of stuff, even if it's crap. Helpful resources. Kathy is one of the #1 most helpful resources in the city. So if you don't have any gear, Kathy will happily sell you some. There's really good resources on Reddit. I don't know if you guys know the website Reddit, but there's 2 really great communities, one called Astrophotography and the other poetically named Space Porn, which are really good resources to post images and have people give you critiques and tell you how you can make it better. This guy, Forrest Tanaka on YouTube, is really great for people that know nothing about the hobby. He explains how to shot for a telescope tube. He explains how to shot for a mount. He explains how to align your gear. Really, really great resource. Clark Vision's a little advanced. Don't be intimidated by the tables and the math on his website. Whatever he says, yeah, look at the pictures, and whatever he says, do that. Because you're not going to outwit Roger. That's just
including buying the $6,000 lens.
If he tells you to shoot at 1600 ISO, you do it, and you don't. Again, I use this software called Pixel-peeping, which can be really gnarly, but these 3 websites are really good for learning it. And my close is, if you're not into astrophotography yet, or if you're into astrophotography a little bit, this feeling, don't worry about it. It happens to everyone, and it's not going to go away. That's all I got.
Thank you very much, Jeff. I think that you got a couple pretty nice looking pictures up there, but you guys heard him say it. I'm not satisfied with the processing of that picture. Didn't you hear them say that? So I'm not sure that I believe that you're not an artist deep down inside.
Give it another couple of years. Pessimistic.
I'm Kyle Williams, and I'm a software engineer, and not to offend anybody in the crowd, but that means I'm lazy. Which seems probably kind of silly that I'm in astrophotography because it is a very patience-trying activity. But that's why it worked well for me, I think, because it taught me a lot about patience to get good at this. So I knew nothing about astronomy going in, and the first thing I did, really, when I got a telescope was connect a camera to it. I found that to be a really good way to learn about astronomy. If you spend a lot of time taking a photo and getting a good quality photo, you kind of want to know about it because you're going to pull out details within that photo and do some research about what it is. And so it's a really good way to learn, so I highly recommend it. I had a low budget at the time, and I had heard everybody say that it's an expensive hobby. And to kind of go off of what Jeff was saying, it really doesn't have to be. And I'll talk about that a little bit. So this is really my first setup. It's an 8-inch Newtonian sitting on an Orion Skyview Pro. It's a go-to. It just tracks with the movement of the Earth. And then this is just a Canon XTI DSLR that I borrowed from a family member. All of it was unguided, which means I wasn't using an auto guider to look at a star and help with periodic error corrections in the mount. I would take single to multiple short exposures. And kind of like Jeff was talking about, you can stack photos. And I didn't know anything about that starting. And this was the very first photo I got. And it's not a very good quality, but you can see that the guiding wasn't very, or the tracking wasn't very good. I didn't have a good polar alignment. I didn't have very much of an exposure, but knowing nothing about astronomy, this got me really excited because I got some color out of the sky. I had no idea that was even possible. So I did some online reading, and the very next night I went out and tried again. And this is the very next night. And I got this photo, which is a little bit better. You can start to see Running Man Nebula up in the upper left-hand corner. starting to get some of the detail of the dust clouds around the outside. And the guiding is a little bit better. Some of the stars are a little oblong. And then a few months later, I read a little bit more and found out I could do some other longer exposures, and I started stacking the photos together. This is all with the same equipment. So I started stacking photos together and adjusting my processing. Again, you can see a little bit more detail in the Running Man Nebula. You can start to see just a little bit more detail around the outer edges. And so I really upped my game the next time, and I tried to get, I think this next photo is about 3 hours worth of exposure. That's combined stacked. And I got this photo, which is a lot more heavily detailed. The guiding was a lot better, and everything's a lot brighter. And to get this photo, I actually took 2 different lengths of exposures multiple times. I took a lot of short exposures to reduce saturation in the core of the nebula, where there's a lot of stars illuminating, which tend to saturate the sensor, and then you lose a lot of detail. So I took a lot of short exposures and a lot of long exposures. So I processed those 2 sets of photos separately, and then in Photoshop I put the layers, I put them on top of each other, and I erased the long exposure area where it was saturated, and that's where you can see a lot more detail in the center. So that's how you, there's different methods to doing that, but that's one way that you can pull out the detail. Yeah?
What do you call short and what do you call long?
Well, it's a good question. It's been a while since I've taken this. I would say short exposure for Orion, because it is so bright. You can even, depending on your ISO of your camera, you could probably take a, yeah, 1600. I don't even know if I was taking them at that, because I was so new to it then. But I'd probably say even as low as 1 to 2 seconds to get the very core if you want to pull up the stars. Yeah. I didn't do that here. You can see I have a whole area in the center there where it's saturated completely. Some people get really high quality photos where you can pick out individual stars and just read. Long exposures, I would say for Orion, I think I tried to stick around 2 minutes because this is unguided and I couldn't really get better than 2 minutes of exposure without starting to see the tracking errors in the mount show in the photo. So the next photo is a completely different set of equipment, lower quality photo, but this is a narrow band image. So the colors are a little bit different, and the details are pulling out. The details that you can pull out are a little bit different. This is again me just starting in narrow band imaging, and I'm going to talk a little bit more about narrow band imaging and the benefits for that in a little bit. This next photo is a combination of narrow band image and a DSLR image. So the great thing about astrophotography is there's tons of different kinds of cameras. There's modified cameras where people take off the infrared filter on those cameras. There's CCD cameras. There's color CCDs. There's monochrome CCDs. People can put many different kinds of filters in front of those. And you can layer those photos to pull out new details. So it is a very kind of artistic expression of the object that you're viewing. So this is the very first photo of the Horsenet nebula that I took, and you can just hardly see the Horsenet out on the edge there. Again, I probably wasn't even stacking any of my photos. I was just taking long exposures and seeing what I could get. After a little bit more experience, maybe some upgraded equipment. Actually, this is after upgraded equipment. I was able to get this photo of the Horsenet Nebula, which you can see this is a modified DSLR versus the last photo was not a modified DSLR. Just go back. So the modified DSLR has that infrared filter removed, and it allows a wider range of the visual spectrum to hit the sensor, and it's a little bit more sensitive in that magnitude. So this is the same exact photo as the last one, just processed completely differently. It's a little noisier, but if you compare the two side by side, there's a lot more details that you can pull out of this one. So within all those photos, I just kind of highlighted all of the things that I want to stress about astrophotography as being important. The first of all is the polar alignment, which is your first initial calibration of the telescope. Is very important, especially if you're not guiding, and even if you are guiding, polar alignment will help reduce any drag within those photos. And if I were to take all of my purchases back, the first thing I would have done is bought a stronger and more stable mount, because the mount is very important. You don't want any movement. A heavy mount is good because any wind at all tends to move that telescope, and any movement of the telescope on a longer exposure. When you start talking about those 2 to 5 minute exposures, any movement. I mean, I've heard of people saying that somebody walked by and it shook the movement of shook the gravel a little bit and caused some movement in the scope. So every minute is precious when it's 2 a.m. in the morning and 20 degrees outside. You don't want to get inside. Auto guiding is another method, and I won't talk too much about that. But that's an important factor. But again, strong mount and polar alignment are really your best friends there. Higher sensitivity cameras are getting very popular these days. There's a lot of new Sony sensors that are low noise, and Jeff talked a little bit about that noise ratio. And some cameras are able to get those long exposures, tend to get a lot of noise because you're just constantly collecting those photons. And higher sensitivity cameras, you get that light sooner, you cut your exposure in half maybe, and less movement. Any tracking error that you might have in your mount would be cut in half as well. I also improved a lot of my processing techniques and software and found new software. I'll talk about that in a little bit. So from that equipment that I was using, this is just the equipment that I'm currently using, which is the top left is actually the camera. That's an SBIG 8300. That's a monochrome CCD camera, so a little bit different than a DSLR. It doesn't have a Bayer matrix in front of it, and what that means is it doesn't have any filters in front of it at all. I actually placed those three filters down there are narrowband filters, and they just cut out little slivers of the spectrum for me so that I'm only collecting a little bit of light. So what that means is I have to take much longer exposures, but I am only getting certain information from that, and I'll show you some examples. And right next to the camera is the filter wheel. So all those filters sit in the filter wheel, and I can electronically control that and swap them out as needed. So to kind of show you some differences between a DSLR image and a CCD image, this is a DSLR with a modified DSLR, so the infrared filter has been removed. This is a Pelican Nebula. And this is a CCD monochrome picture with the hydrogen alpha filter in front of it. So a lot more detail, a lot more contrast. However, the cost of a DSLR is about half of what you're going to see in a CCD. At the very least, CCDs can get very expensive. So DSLRs I highly recommend. They're a great tool to use, and you can do a lot with them. So compare those photos. I highly recommend the DSLR, but the CCD cameras are a good way to upgrade in the future. So this is a photo I did of the Pelican Nebula using that same frame from before, the hydrogen alpha, except this is in a Hubble palette. And what that means is I've taken 3 different kinds of photos here. I took the sulfur 2, I used the sulfur 2 filter, the hydrogen alpha filter, and oxygen 3 filter. And I processed all 3 sets individually. So I stacked each set individually, and I processed them individually, and I took 3 layers into Photoshop and I attributed them to a color. And that the color set I chose was the Hubble palette, and that means I assigned the red frame to the sulfur 2, the green frame to the hydrogen alpha, and blue to oxygen 3. The cool thing about that is that you really have the freedom of choosing how many frames you take of the hydrogen alpha, how many you take of the oxygen 3 or the sulfur 2. And there's other filters out there too, and you can assign different colors to pull out different kinds of details from those images. And this is just showing you from the spectrum where those particular filters, what they're filtering out. So you can see the hydrogen alpha and sulfur 2 are actually in the red spectrum, whereas oxygen 3 is closer to the green. That's why they call those false color. Because hydrogen alpha is actually in the red spectrum, but we're assigning it to the green. I won't talk a whole lot about the software I use because we could spend hours just talking about one piece of the software. For guiding, I think you'll see most of us use PhD guiding. It's a very common software. It's made by the same company as Nebulosity, which is also a fantastic program for CCD, DSLR, framing and focusing, and image capturing. It also does some processing of photos as well. As Jeff said, that he used Backyard EOS. I used it for a very long time. I highly recommend it. It's very easy to use and easy to get started. For stacking, I've always used Deep Sky Stacker. I have not tried any other applications, but I've been so happy with Deep Sky Stacker that I stuck with it. It's very easy to get started with because there's a lot of just one push buttons to stack all your photos. But then there's a lot of further advanced options. You can really dig in and choose which algorithms you want to apply to all your photos. And then for post-processing, I use Photoshop. And for an image repository, I recommend Astrobin. And even if you're not an astrophotographer and you just want to look at some cool photos, use Astrobin. About 6 months ago, I got started in the open source development of Astrobin. So I have I've been doing some of the development on it, so I highly recommend it. It's very well built and it's well supported, and there's a huge community of people out there. So even if you're not posting photos to it, you can go there and like photos and share them with other people. And really, the last image here is just of Lovejoy. This one I took, I think, late last year, and as Jeff said, these are this is probably one of the hardest subjects I took because not only is the sky moving, the comet's moving as well. So in this photo, I had to shoot the ISO up really high so that I didn't. So I was able to get enough frames quickly to stack and reduce the amount of noise without having the comet spread across the sky when I went to stack it. And real quick, I was just going to mention, if you want to look at any of my photos, I'm on Astrobin. My username is Quantum64. I'm also building a roll-off roof observatory, and you can read a little bit about that at areaobservatory.com. And I want to just show a quick photo or a video of the Lovejoy comet movement, and just to kind of show you how difficult it can be to capture.
You got it, Kyle?
I think I got it. I think I got it. No, it's yeah, I might need help. So it's a very short video. So you can see, and the different rates of movement are due to just different exposures that I was taking. And the light's kind of flickering out, but you can kind of see how quickly it moves across the sky. And those are all of my frames within that time. So I wasn't able to get very many frames to do that, but it's kind of neat to see the movement of that.
Are we seeing action in the tail of that comet?
I think we are,
Noise, photos?
You can see that my mount's not tracking perfectly, which was frustrating at the night. You can see some movement.
Satellites.
Yeah, maybe ever so slightly. That's all.
guys maybe any question?
Oh yeah.
So since when are you doing astrophotography?
How long?
Yes.
4 years.
Okay.
Yeah.
2 years, 4 years. Okay.
All right, so I'm Sorin. I've been doing astrophotography for about 2.5 years now. And as you'll see in the presentation, I am what Jeff calls a pixel peeper. I've just, constantly tried to get better and better and more accurate as I go. I've actually tried to document a lot of the trials and tribulations I go through at the blog up here, soggyastronomer.com. The name originated because I came from Seattle, and as we know, they get about as much rain there as we get sun here. And I want to start out by talking about the rig I actually started out with. And actually the location. I was in Seattle at the time. And this is actually where I did some of my astrophotography from, was my backyard, overlooking the Space Needle in downtown. So, talk about light pollution. But I started out with a 6-inch Schmidt-Cassegrain telescope, which was a mistake. Because that's a very long focal length scope, 1500 millimeter. And that's very unforgiving of any tracking errors, as opposed to shorter focal length scopes. So, first mistake. On the positive side, I started out with an equatorial mount, a basic CG5 mount, so the entry-level equatorial. And a Canon T3i DSLR, again, sort of entry-level, bought a refurbished model from Canon. So I tried to get in, with a decent setup, but not spend too terribly much money doing it. Since then, I've gotten 2 other telescopes. I got tired of that shuttlecock artifact in the corners of the image that you get with the SCT or the Newtonian, and wound up getting a Astrotech 6-inch Ricci-Crichton astrograph telescope that eliminates that artifact, along with a field flattener to get a nice field view. And I also got a shorter focal length instrument, finally, to make it a little easier on myself after the first 1.5 years, which was a Stellar View 80 millimeter apochromatic refractor, so smaller scope. That's actually the one pictured on the mount there. Still using the same camera, and added an auto guider along the way. So as I sort of progressed with the photos I was taking, I was trying to take longer and longer exposures and realized, well, I can't do this without guiding. And most recently upgraded the mount from the CG5 to the CGM. Huge upgrade, actually, particularly for the longer focal length scope. And of course, adding the laptop into the mix for auto guiding and acquisition. So, we started out pretty basic, and just over the past 2.5 years, progressively added one thing at a time, adding a little complexity, adding a little more quality as I went. And since Orion seems to be everybody's favorite target, it's one of mine too.
Yeah.
And there's a very good reason for this. It's the object that just keeps on giving to the astrophotographer. Because you can do really short exposures and get something really cool. And you can do really long exposures and get something really cool. And you can do combinations of really short exposures and really long exposures and get something even cooler. So it's one of those objects that you can just keep going back to as your skills improve and always draw a little more out of it, which is just fantastic. So this is one of my early Orion images. And the thing I loved about this was you can see the 4 stars right in the middle there, the trapezium stars. Really short exposure, just 6 seconds. So that's what I did when I was first starting out. 1 year later, this is about what I was doing. This was with an upgraded telescope and auto guiding, and starting to do image stacking and longer exposures, so 2-minute exposures. And then this is the most recent one, which is actually a mosaic, including the horse head. So this is with, again, a different telescope, the shorter focal length, 80 millimeter. And you can actually pull out quite a bit from the horse head, even with the DSLR cameras. So I have another version of that I processed a little more and pulled even more detail out. But for the mosaic, I tried to keep it a uniform processing across the whole field. And again, this is actually 2 different sets of exposures and then merging them together in Photoshop, aligning on the stars. So that's sort of the progression I've done in terms of acquiring images. You know, I started at the wrong end of the focal length spectrum and sort of found my way back to the shorter end of the spectrum there. And now that it's galaxy season, I'll get the longer focal length scope out again. But I do want to talk a little about processing, because this is one of those things that trips a lot of people up, and certainly has tripped me up quite a bit. This is a raw image captured on my DSLR using nebulosity. And you probably have no idea what's actually there other than some stars. This is that same image, exact same image, in Lightroom. And the difference is Lightroom takes all the information that's stored on the digital camera with that raw file and actually makes use of it to pre-process a lot of the image for you. And you know, Kyle mentioned being lazy as a software engineer. I've got you beat. Because I absolutely love DSLR imaging, because so much of it can be done for me on the processing side. So with a few tweaks in Lightroom, I can really pull out more detail here. And that's still just a single image. That's without any stacking yet. So there's still a lot of noise reduction I can do, as Jeff and Kyle showed. So basically going from something like this to that, just by using different software. And really just using software that makes use of all of the data that's being collected by your camera and all the smarts in the camera.
Did you try adjusting the curve up to the right hand of the Gaussian curve on the nebulosity side? Yeah, there makes a big difference where you set those.
Yeah. Well, yeah, so for this example, these 2 images, this is exactly how it was captured by nebulosity and how it was recorded by Lightroom. Right, so no changes at all.
Looks like Lightroom stretched it for you.
Yeah,
Yeah, it does. Well, yeah, the camera stores a lot of the white balance information and all these other details that nebulosity ignores. Lightroom makes use of them. So all the data is there in that nebulosity image. It's the same file. It's just, I'm lazy, right? If Lightroom wants to do a lot of the processing for me, I'm happy to let it. And it makes it really easy to do, you know, a little more stretching. And then what I actually do in my whole processing phase is I'll do the initial stretching and a little noise reduction in Lightroom, copy those changes to my whole set of images, and then export as 16-bit uncompressed TIFF files, stack those in nebulosity, and then do some final processing in Photoshop. So when I was starting out with the processing the beam velocity, taking the dark frames, taking the flat field frames, I would spend probably a whole day or two processing one image. And at this point, I don't do any of the flat frames, I don't do any of the dark frames. A lot of the pixel noise gets canceled out by the filters in Lightroom. It does a really good job with that. And I spend probably about an hour, maybe 2 hours processing an image. So, like I said, I'm lazy. But I get good results for it. So, some of the things I've learned that I like, particularly with DSLRs, is in addition to all the great stuff the camera does in pre-processing the images for you with the right software, you get a great preview of what you're actually looking at from the LCD on the screen that you don't get from the CCD cameras. So highly recommend them for that reason alone. And the articulating screen on some of the models is really handy when you're trying to bend down to look at the thing when it's pointed up like this in the wrong angle. Very handy. A Batinov mask, a focusing mask, is hugely valuable. So this is what the mask actually looks like. And this is the pattern it produces on a star. So you get this crosshatch pattern, and then another hash down the middle. So here are the crosshatches, and that middle one. And as you adjust the focus, that middle one will move up and down between those crosshatches, and when it's dead center, you're dead in focus. It makes it really easy to fine-tune focusing.
What do you call that, Sorin?
Batinov mask.
Batinov?
Yeah. There's actually, you can buy them, they're really pretty reasonable, 10, 15 bucks. They come in different sizes. There's also resources online to just create a template where you can print one out. And you can buy like a cheap little 50-cent file holder from Office Max or something and trace it around and cut it out of one of those. And like I said, short focal lengths are your friend when you're starting out. I learned that the hard way. And there's a lot of great objects to image at short focal lengths. I don't have it in this presentation, but on the cover of the last Denver Observer was an image I took of the Pleiades and Comet Lovejoy. That was with a 50mm camera lens. So you don't even need a telescope to take some really amazing astronomical. You can use whatever camera lens you happen to have. And something like the Sky Tracker, like Jeff was talking about, is really cheap entry point. And then it is all about the mount, having a solid base. Learned that the hard way too.
Name one astronomer that hasn't learned that the hard way.
Yeah.
Warner and Swayze.
Well, I'm hoping there may be one in this room who's listening right now who doesn't have to. That's the goal, right? So, Jeff talked about what he really loves about astrophotography, and I want to do a little bit of the same. I love the challenge. It's one of those things, like looking at those images of Orion that all three of us have showed so far. There's a clear ability to keep progressing just with that one object and do new things and different things, and just challenge yourself in new ways. So another example of this is the International Space Station. So that's what that streak is there. And the slightly dimmer streak is actually one of the cargo ships that was trailing it at the time, preparing for docking. So again, that's just with a regular camera lens, and that's just on a fixed tripod. And that's a 10-second exposure. So really not difficult. When you want to get difficult, when you want to challenge yourself, you can go for something like this, which is a very long focal length and a little out of focus, but you can tell it's the International Space Station, which is pretty cool. Related to that is be a mad scientist. You know, try crazy things, try different things, experiment with how you process photos, and it's kind of a combination of art and science, and you can be anywhere you want to be on that spectrum between them. I've seen some astrophotographers that process the heck out of things, and they just really pop. Right? They don't look natural anymore, but that's not what they're going for. People do mosaics with astrophotos. They do some crazy stuff. It's fantastic. So go crazy with it. Have fun. And as Ron was saying in the beginning, there is a eclipse coming up in the morning. And eclipses make great targets. You don't even really need a tracking mount to do it. You just need a camera and a tripod. As a matter of fact, I took this photo back in 2008, before I even had a telescope, before I was thinking about astrophotography in any real way. And I took it with this little compact camera. So we're not even talking about a DSLR or anything. This is just a little point and shoot camera with, you know, a 35mm lens and a tiny little sensor. And that got me a nice eclipse image, and there's actually Saturn, there's that little dot there, and Regulus on the top. So don't be intimidated by not having the right equipment. You know, that's part of that whole be a mad scientist thing. Try stuff out, see what works. I've actually seen a lot of people do some pretty impressive photos pointing their cell phone camera into the eyepiece of the telescope. It can be a frustrating experience sometimes, but I've also seen some great pictures that way.
It helps to use a great big telescope.
It does.
Like the one at Chamberlin.
And with that, that's the end of my presentation.
Excellent.
Okay, these are running just a little bit longer than we thought they would. How are people fixed for time? Do we have time for a couple more?
Sure.
Keep going. This is good.
That's why we're
Okay.
here.
That's what we'll do. Mean for you to drive home in the dark this once.
Okay, I'm Darrell Dodge, and started with taking pictures of the sky in the wrong way. I bought an ST8 astronomical camera, which was impossible for me to get anything out of. So I had that for many years until I got a DSLR, and that's when everything started happening. So I just have graduated to an astronomical camera that I haven't used very much. But all of them are with a DSLR, and it's a great way to start. And I hope I can do this the right way.
Right arrow there.
Okay, there we go. Okay, so here's what I'm going to talk about. I'm going to talk about my equipment platform, auto guiding equipment, imaging cameras, and then I'll do a bunch of images, old ones, new ones. I'm going to talk about workflow, but I'm not going to really concentrate on this very much. It'll be in the presentation. It's really detailed as I've written it, and I may work through. Evolution of images at the bottom from 03, and that, well, actually, the earliest one I don't have is not, I don't have any that I made with the ST8. I have one with actually a SAC-8, which was an old astronomical camera that cost about $100. And then at the end, I've got a group of images about my adventure in drawing out the hydrogen spumes in M82. So here's in my backyard where I don't do a lot of imaging, and you can tell there's a lot of trees. There's stuff on the mount up there. This is an 8-inch Ritchie Chrétien. It's like the one that Sorin has, but a couple inches more. I have an Astrotech refractor on the top. My attic camera's on the back. I have close-ups of these two. You'll notice the button-off mats on top of my little patented screen for observing out when a lot of people are around. I have a flash drive laptop that's very small, hardly uses any juice at all. It has a nebulosity 2.3 on it, and then the PH2 auto. And then if I'm in a remote area, I have a marine battery and an inverter, and that will pretty much run everything. So here's the mount, close up. I bought this in '04. I did a lot of imaging, or a lot of observing with this. The Herschel 400, the Herschel 2, all this observing programs was great. I started out, however, with a mount that you had to actually move to. It was a start-hopping mount. This is a close-up of what's on the tube there. You'll notice that under the refractor, there's a thing called a mini-max. I used to use these rings, but the rings, they flex as the scope moves, and if you're auto-guiding or imaging with those, you end up with a problem there. It's a kind of a rail arrangement with clamps, and it really holds it into place. You can tell that there. And then the guide scope out in the front, I actually made this. I was going out to the Alcon out in Bryce Canyon, and Orion was coming out with a small auto-guiding scope, but it wasn't going to be out until after I left, so I made one of my own. And I used to use a large one, but it turns out that with all of these new auto-guiding programs, you really don't need a large scope when you auto-guide. You can use one, but you don't have to use a large scope. So, here's my attic camera. You'll notice it's way back off of the telescope. This is a characteristic of these Astrotech scopes. And it's a cooled camera as well. One of the issues with the DSLR, you can have them cooled, but if they're not cooled and you're out imaging in August, a warm August evening, you're going to end up with a lot of noise in your camera. And that's can really be a problem. It was a problem with my images that I made at that Bryce Canyon Alcon, where I did a lot of imaging. But this is a cool camera, and it really is. It really stays cold, and with cooling like that, it really reduces the noise quite a bit. And here's an image I took of the Sculptor Galaxy at Chaco Canyon in a campground there. I didn't have any power. I just used my batteries, and this is way down low on the horizon over here. And one of my objectives in going down there was to get an image of this. This is probably about an hour and a half of exposures that are about 4 minutes, maybe a couple as long as 8 minutes. This is, it is really possible to take images in your backyard. And this is one I took of the Orion Nebula when there was all kinds of snow around and everything, and all kinds of sky glow and everything. And I got a nice, I had to created a layer mask of the area right there around the trapezium. I chopped it out of there and I pasted it in, and that's how you get all of the detail there. The image I used for that, and this was made with a small refractor. It's about 8 around at the end. It's very, very small. The image for that was probably less than half a minute, and then the others were at the most maybe 2 minutes. And what I like about this one, it brings out all of the dust that's in there. With that, in Orion, there's an incredible amount of dust all through it.
Is there any filter?
Let's see. I might have used a clip-in ALS Astronomical, which blocks out a lot of the light pollution. Nebulosity handles that very well. It kind of is on top of your image, and when you do a color correction, actually a background correction, it just blows it all away. This is what I call the industrial area of Orion. This is M78 with a bunch of other ones. I really like these gritty ones. Actually, I'm not real happy with the exposures on this thing, but it also has the McNeil Nebula too, which is there's a thing that looks like a smiley pumpkin over there on the right, and then there's another brighter one. It's the one right in between those. It looks like it's 2 images. It keeps changing all the time because it's a star that's kind of in back of a lot of dust, and as that stuff changes, there are times when it kind of goes away. Over here is actually Barnard's Loop on the left. There's a little chunk of it there that goes around here like this, and this is above, of course. This is one of my earlier images, the cone and Christmas tree. This was from late in 2011. This one was my most amazed experience with imaging because of all of that blue that came out. I use a modded camera, and it really brings out the red because you're removing the IR blocker that's included with most of these cameras. But it also, actually the modding enables you to bring out a lot of blue as well. The Christmas tree, actually the top of the Christmas tree is right by the cone there, and then it goes up like this. I just like it like this, a little bit better. So, and this image here was only a little corner of a larger image. I probably spent about 40 hours on this one. It was really, I had to really tease out a lot of stuff because it was very, very small and was blown up quite a bit. And I kept on making mistakes and having to go back. One of the things that you really have to do when you're working with these images, you have to make a copy of everything you do.
Yeah.
If you don't, you're going to go back, I missed that one. And, that's only happened a few times. And again, this is with, this is actually with a Newtonian. It's an 8-inch Astrotech. I was really happy with this image. Just won a prize on actually on the Digital Astro Yahoo. So it was hard to do that. Oh, here's everybody was talking about comets. This is one. I was out at Deer Trail with Ted Cox, and he went, "Oh, there's a comet in the sky," and I went, "Oh, okay, I'll go over and image it." And I did. This was a really small little comet. It was one of the ones discovered with a linear scope program. And again, I had to process the stars and the comet individually using clipping. There's other ways. There's a number of ways of doing this on the web. You can look it up. The web is an incredible place. You can just kind of, actually Google stuff and bam, it all comes up. So, there we go. I like stuff that people don't do. This is a running man, but actually turned around. He would be the one that Ron was looking at down, where were you down?
Argentina.
Yeah. And you'll notice all of the dust in the image there, as is always in a running. But what's interesting about this is the running man is running either way you look at him. But I call this the alley-oop image because it looks like alley-oop. And then here's the old Eagle Nebula. It's kind of blurry. It was low in the sky. This is one of the earlier deep sky images I did with the new Richie Chrétien, which I haven't had that long. It's just a couple of years ago. Now here's my stuff on workflow. Aligning them out. I spend a lot of time aligning them out. Everybody is going, are you imaging yet? And I'm still aligning. But I try to get it as well. I've recently learned that if I try to do very polar alignment, that it really doesn't work as well. If it's off a little more, it allows the autoguider to do more. And it's not just going it's doing larger movements, and it actually works a little bit better. I capture with nebulosity. I also stack with nebulosity. The program is incredible. I do everything up to when I have it all stacked and all ready to go into PS Creative Suite. And you can do your master docs, darks, add pixel maps. When you're looking at an astronomical camera and you have an image, you'll notice these trails that are going along. And that's a pixel that's bad that is light. And it's creating this little trail as the image moves a little bit in the sky. It's always going to be moving as you're auto-guiding. And that's a way of actually eliminating those. So, a little more, okay, this is pre-processing and getting it ready to go into Photoshop. And again, there's more detail here than I want to get into, but this will be available wherever we put this, probably on the web or whatever, or on the YouTube channel. So here's all the stuff that you can do in Creative Suite 5. You get your 3 images, the red, green, blue. You can do it bevels and curves, layer masks, as I did before. I created a mask and I plopped it down on another one. I'll have a little bit more on that later. Noise reduction, hue and lightness. Clone tools where you're screwing around with stuff like you'll have trails of satellites that you have to get rid of. One of the images later, the angel had about 100 trails in it because it's in a place where there's all these GPS ones that are going around every half hour, every quarter of an hour. So just streak with these, I had to use that function to get rid of. I have used hydrogen alpha, which is a way of actually pumping up the red. With a DSLR, you really don't need that. So, and then astronomy tools. Astronomy tools is an incredible plugin. Neil Carboni, it's on the web. It costs $24. It has all kinds of really great stuff. One of the ones I didn't mention will reduce your stars a little bit. If you have mind mount, isn't that great in terms of keeping the stars small. But you can just keep boop, 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 and it will kill your stars a little bit. Gradient exterminator is great if you have problems with dark areas on the edge of your image. So, and that is
Daryl, that's a plug-in?
yes, a plug-in. Smooth and remove any banding that you have. If you have a lot of noise, there's going to be these horizontal bands, and you have to get rid of those. I had a lot of those from Bryce Canyon. Anytime you're creating, anytime you're working with any of this stuff, you have to blur or actually, feather the edge of the area that you're working with. Because if you don't, you end up with a line there. And it's extremely easy doing this, but you have to do that every time that you do anything in a small area. And if you do one and you realize that you didn't remember, get rid of it right away. You will regret it later on. So start with larger objects and then smaller areas. And then whenever you apply noise reduction, you want to use, and it's important to zoom in on your image because you have to be aware of what's going on right around your stars because it'll still be there and you won't really be aware of what it is, but it's important that you have to watch out if there's these little black areas that start appearing around your stars. Let's see, okay. Then high band pass, this was Hallis, Tony Hallis. He had an article in Astronomy about this, and it just changed my whole end of how I process things. It's a way of really bringing out a lot of the detail in your image. And all of this will be in there. This is really important. So now here's my progress. Here's SAC 8 over on the left in 03. And there's a later one with my Canon, and I think that was with my 11-inch. So I did start imaging with an 80-inch, an 80-millimeter refractor in Orion, but I was still doing a lot with my 11-inch. It's a little harder. So this is my progress. Over on the left, of course, that. Over on the right, Angel Nebula. And I really like going after these obscure things in the sky. There's very few images of the angel out there. There's another one that's called the Angel too, but I was really thrilled about this one because I didn't know what I was going to get. And that's what I love about this, is that if you go to an area that you really don't know a lot about, you hear about this thing, you go in there and you start to bring out this image, it's really a thrill to do this. And, this was really a wow experience. And this was the one that had all those streaks. It had about 100 of them, just crossing them like this, and I had to get rid of all of them. And it was hours and hours and hours. Let's see. Every once in a while, it kind of hangs up.
Hit the right arrow there.
Oh, the right arrow? Okay. Okay, that's. Wow, what just happened? Murder. No. Oh, did we lose it? I don't know what's going on here. Oh. Okay, that. Okay. Okay, so this is with a Meade DSI. I tried all kinds of things. The Meade. And that's a pretty scuzzy image over on the right. But I kind of liked it at the time. I thought it was great. So, and then here's an example of how the different scopes work. The Newtonian over on the left, and then the Richie Chrétien. It got me in a little bit closer, a little more detail. This is really stretched quite a bit. So that's with my 8-inch Richie Chrétien. But this again is another reason why I like it, because you get in there and you can really, have a look at what's there. Let's read it through.
Which messier object is it?
That's M33. Excuse me, did I do that? I didn't, I'm sorry. I could have added a lot more stuff on this. So, okay, now we're going to go into this whole process here. I hope not using too much time. This is what comes out of nebulosity after you stack. This is M82, which is the Chamberlin major. It's a computer M81. It's called the exploding whatever. Yeah. So, and then here's what I ended up with after my processing. And I looked at those, at the hydrogen spumes there, and I went, you know, that's just basically noise. You know,
Yeah.
I was highlighting the area, and I was like, you know, that is not a really great image. This was made with an 11-inch, which is the reason for the big stars. Schmidt-Cassegrains, especially old ones like mine, are notorious for having lousy star images, and that's really more out. But I was unhappy with this, and this is what was printed in the Observer, I think. And every time I look at that, I just cringe. So I really wanted to learn what was there and what I could get out. I stretched it, and I highlighted these areas where the spumes were, and you notice there's a little more detail there. I said, oh, wow, this is pretty cool. So I started working with that a bit more, and I made individual image masks, or layer masks. Here's the top one here. This was created by just choosing the darkness. There's a tool that you can do that with. And drag that out. Now, you know, it looks kind of blurry and everything, and I wasn't real sure if I was going to be able to do anything. Here's the one on the bottom. It still looks blurry, you know, but it has these, you know, striations in it, and I kept on going. And what I learned was that, you know, here it was when I put it on the background, it lost all of the darkness and brought out all of the color. But, you know, obviously that's not great, but I was able to do some processing, and this is what I ended up with here. I reduced how bright it was and did a little bit of blending and playing with the edges. So you'll notice the star. I lined it up. On this I cheated. I used the Hubble image as a way of lining up these things. And then that star there, it's in the open space. So, and this is quite a galaxy. This has always been the galaxy that I've probably enjoyed the most. When I started observing in the early 80s, this was the one I always came back to. So then here's with the bottom, with a little detail. I had another step to this with the same process, but I mentioned that. So, and then playing with it, here's what I ended up with. So you can tell there's a lot of detail in there. All of the detail, all of those spumes, the hydrogen blowing out of this exploding galaxy. And
Have you compared this to other images of the same galaxy?
mm-hmm. Yeah, it looks pretty much like the Hubble image.
Okay.
So I made it with a little cheap camera.
Those details are real. That galaxy is hyperactive.
Yeah, right, and those are real. Those
It's
are
an
real.
extreme starburst galaxy, and the radiation pressure is just blowing stuff out of both sides of it.
Yep, all of those are real. And then again, here's what it looked like.
It was a big supernova in there last year.
So that's my presentation.
What I have is a video. So, what?
Spacebar.
Okay.
Okay. Yeah, what I have is a video that I spent 2 full nights working on because I couldn't sleep during the day because the feet were acting up. But I managed to, get the video done, and I revolved it around an image that I scanned with the scanner that I took in, I believe, in 1998 at the Texas Star Party, which was a very wide shot of the Sagittarius star cloud. And I put 3 of them together. You got Scorpius on one, and Sagittarius, and Scutum in the other. And the scanning techniques of the scanners and the especially PS6 Photoshop, there's been a lot of improvements. Plus, my computer's a lot faster than the old ones. And I could take these ungodly 1.3 gigahertz or gigabyte images and smack them together quickly without, just waiting for it and doing all the adjustments and stuff. And yeah, that's just the intro. But I'm going to, my first thing is my own history. I started way back in the 1960s, around 1968. I had my own darkroom, and then, of course, I decided to shoot everything, sky or whatever. And this is my own larger, and this darkroom was in the basement of my house at the time. Like I said, there's been 4 generations of my family living there. So see the wall is falling apart, and those little slabs date back to the Great Depression. Because my grandfather put the storeroom, and the next one, my mother and one of her sisters were there, and well, my grandparents raised 7 kids. And this is my earliest surviving astrophoto. I actually found that the other night, going through a bunch of photographs. And that right one is Jupiter, and that's how I found the exact date. And exact time. And that picture was taken with a box camera with 120 roll film Tri-X. 30 seconds.
It's amazing what we do with 30 seconds now.
I found out it was on a Wednesday morning. It was over Easter vacation at the time. I was a senior in high school. And I took that. And these are my cameras and lenses. And I use every one of them with both film and CCD except for the Zuko lens. But my first big camera was very noisy. As a matter of fact, I had them put a new chip in it before I could sell it. Because the new one had the external guide port and it had all the bells and whistles that my old one didn't have. And this was my first serious attempt at astrophotography. I bought this in '84. Turns out when I bought my 18 inches, it was also an '84 model, but I bought it used. And it's the same scope. Notice everything's different, the tube, everything. It's changed, even the drive electronics. And this is my wide shot using the Mamiya RZ medium format camera. And it was done at the site. And one of my first mosaics was actually a display at where I used to bring down at the astronomy days. And that's my 18-inch. I was at my aunt's cabin area, so I like this picture. And this is my CCD setup. I made this because someone was asking me how did I do it, because they want to figure out how to hang their CCD on the scopes so it won't be falling on their feet. Because the guy had an embolism from that. It was really nasty, so. And now we go from the history to what I took. And these pictures that you'll see was taken with the
with Mamiya lens, but I had to stop it down to f5.6 because of CCD and in film is different media. And otherwise I'll get very bloaty stars, very fuzzy stuff. And the aperture of this is the size of a US nickel. So this is how you can, what you can do with CCDs. And of course, they'll start getting into, and I highlighted that area is a, uses the same lens as that one, but it's like I say, it's a nickel, it's a mosaic of 4 images of the row of 50 area. And it shows all the details, stuff that didn't really come out when I tried to film. And I even annotated all this stuff. And we're going to M4 right now. And that was taken with my 10-inch, actually. And here's something Jack is very familiar with.
Yeah.
He'll tell you stories about that.
Oh, yes, he will.
I think it's May 2010. Denver Observer's got the story of that in there.
Amazing. Real amazing. And you'll see all these other images. He'll zoom into a frame that I made out. I wouldn't make more, but the lenses and the camera got stolen a couple of years ago. And being out with this feat, it didn't help either. But that would have been an easier setup where we just go out to dark sky site and rest somewhere while the thing is guiding on its own. And here's M6 and M7. And those are real colors. I noticed that on film images when I was trying to put that earlier mosaic together. There's such coloration, especially down near the hub. And that is actually dust filtering out the blue and blue light. So that you got all these rusty colored things. And that's 2 images mosaic from the 10-inch. And this was a 2-image mosaic from the 18-inch. I'm trying to get as much detail as I can out of that thing. Also with the, all my scopes have been long focal length. But before, my first sensors were huge. They were 35 millimeter size. Consider that little tiny chip I got in my camera now. So I'm used to doing the long focal.